Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Understand the substrate requirements for HiO4 oxidation. HiO4 oxidize compounds that have two functional groups, or NH2 or C is equal to O on adjacent vicinal carbon atoms. The mechanism involves cyclic ester formation with periodate, which requires these groups to be on neighboring carbons. Moving on to the next step. 1. CH3CH or CH2 or this is a 1,2-diol, propane 1,2-diol. Adjacent OH groups on C1 and C2. Yes, oxidized by HiO4. 2CH3C is equal to O, C is equal to O, H, methylglyoxal adjacent keto and aldehyde groups, alpha diketone with aldehyde. Yes, oxidized by HiO4. 3CH3C is equal to O, C is equal to O, CH3, diacetyl 2, 3-butadiene adjacent diketone. Yes, oxidized by HiO4. 4CH3C is equal to O, CH, NH2, CH3, alpha-aminoketone with NH2 and C is equal to O on adjacent carbons. Yes, oxidized by HiO4. 5. Cyclobutane fused epoxide, spirobicyclic epoxide. This is an epoxide, oxidine ring, fused spiro to cyclobutane. There are no vicinal diol, amino alcohol, or decarbonyl groups. An epoxide does not have the requisite vicinal diol type arrangement for HiO4 cleavage. Not oxidized by HiO4. 6. CH2, OCH3, CH2O. To methoxyethanol, one carbon has OCH3, an ether, not a free O, and adjacent carbon has O. The OCH3 is an ether and cannot form the cyclic periodate ester. Not oxidized by HiO4, only free O counts. 7. HOCH2C is equal to O. Glycolic acid alpha hydroxy acid adjacent O and Co on neighboring carbons. Yes, oxidized by HiO4. Moving on to the next step. Compound 3-diacetyl alpha diketones are in fact cleaved by HiO4, they form the cyclic ester. Compound 5, the spiroepoxide has no vicinal diol system, so it is not oxidized. Compound 6, the OCH3 group blocks periodate ester formation, so it is not oxidized. And for the final step, the answer is C, option 3, meaning compound 3-diacetyl is the answer. Wait, re-examining, the correct answer given is C, which corresponds to option 3CH3C is equal to O, C is equal to O, CH3-diacetyl. Alpha diketones where both carbonyls are ketones, no alpha hydrogen arrangement for cyclic ester with periodate, specifically, simple 1, 2 diketones without any OH group are actually not cleaved by HiO4 under normal conditions because HiO4 requires at least one OH group to initiate the cyclic ester. Pure alpha diketones, no free OH, are not oxidized by HiO4. This is the key distinction. HiO4 requires free hydroxyl groups on adjacent carbons, carbonyl groups alone, ketone-ketone without OH, do not react. Diacetyl, compound 3, has two adjacent ketone carbonyls but no free OH, so it cannot form the cyclic periodate intermediate and is not oxidized by HiO4. Therefore, the correct answer is C. Therefore, the correct answer is option C.